You're 5 or more years deep into your IT career. You want to pivot into a cloud architect role, and the SAA-C03 is the gate. But every guide either dumps 200 services on you with no order or jumps to practice tests you can't even read yet. Sounds familiar? That's why we built this series. This is day 1 of our complete AWS Solutions Architect Associate program. And at K2 Academy, we have helped 46,000 plus IT professionals pivot into cloud careers, including Srikar, Saif Rahman, and Roopashree, all working as AWS Solutions Architects today. This series is built for working IT professionals, system admins, DevOps, and network engineers pivoting into cloud architect roles that pay $150,000 to $300,000 in the UK, US, and Canada. And the exam is built on the AWS Well-Architected Framework across 4 domains: secure architectures at 30%, resilient at 26%, high-performing at 24%, and cost optimization at 20%. And you will see this framework in every video of the series. And today we start with the foundation everything else sits on: AWS Global Infrastructure and the core services. So let's get into it.
Okay, guys. So first of all, let me tell you about the agenda of the day. This is the day 1 agenda. I'm using Miro here, right? So Miro is a little dynamic. You can create PPTs, you can create your PDF files, diagrams, everything. This is really dynamic whiteboard. So AWS Services Overview, then AWS Global Infrastructure, core AWS Services. So we are going to cover introduction of these services, introduction to EC2, S3, RDS, VPC. Then we'll take a little talk about pricing and support plans, because we have many other support plans in EC2, right? Because when you launch your EC2 machine, we call it as a EC2 instance. That virtual machine we create in AWS, we call it as EC2 instance, or sometimes we call it as a virtual machine, right? So when you launch your EC2 instance, we select first of all the support plan. We have a various plans. We will discuss about all these plans. But very first, let me show you. I'll not take much time because most of you know about what is cloud computing. But in a second, I'm going to explain. So one thing is very clear: for cloud computing, internet connection is mandatory. Why? Because cloud, you are not inside your data center. You are accessing those data center from remote location. And to take remote, only the internet is the back. So through the internet, we are accessing those data centers. AWS has its own console. AWS has its own console. And this console is known as AWS Management Console. So when you log in into your AWS account, this is the first screen you see. Now, tell me, how many of you have AWS account with you? If you don't have, you please create your AWS free tier account. It's a very simple. You simply go to AWS free account. You simply click on AWS free account. Okay, we have AWS free account. This is the link. You click on this. It will ask you to create a free account. Here you create a free account. Okay, click on free account. Provide all the necessary information in order to create a free account. For example, you don't have new to AWS, you can just click on sign up and simply create your AWS account. So AWS will ask what is the email ID you are using. Please remember, this email ID should be a fresh email ID. You have not used this email ID as before. And account name could be anything as per your choice, as per your discretion. You can type your account name and click on the verify email. As you click on the verify email, you will get some verification code on your email that you shared here, right? That you typed here. So in next screen, I cannot go actually on the next screen. The reason is very simple. Let's say I'm writing my ABC, whatever is there, and Gmail. So I'm taking a dummy email. And here, let's say this is K21 training. Okay. And let's say verify email. So on this email, for example, you have this email. So on this email, definitely you will have some verification code. You copy and type that verification code here and click on verify. And later on, it will ask about credit card or debit card information, which is really important to show your identity, right? So what you are doing, you are showing your identity through the bank verification. Not only this, the transactional point of view, this is a very important step. AWS will not charge anything without your permission. Number one. Number two, when you create your new AWS account, AWS provides you $200 credit. It means if any billable service you consume, right? So that amount will be debited from that particular amount. So you have not to worry about this, and this is very simple. And while you are just proceeding, registering it, so you always choose a basic plan, not a business plan. Business plan is a basically paid plan. So you have not to select a paid plan. You have to select a basic plan. Basic plan is a free plan, right? So this way you can create and you can start using your AWS. So, but when you first log in into your AWS account, you will see this kind of a screen. Right hand side on the top, can you see the username? The username is a root. So this is the default user. Root is the default user in your AWS cloud platform. Is it? This is the default user, and and this is not a good practice to actually use default user. You should always create a user. So what I'm doing, so these are some necessary steps that I'm telling you. This is very, very important. So please note down, because when you start using AWS, you have not to use root account. It is not recommended by AWS. It is not a best practices. So what you will do, you will go to IAM. IAM. What is IAM? IAM is a service in AWS to create and manage users, groups, roles, and permission. It means if you want to create a new user, which service you will use? IAM, Identity and Access Management. See, one thing is very incredible in cloud computing. Let's say you want to create a machine. It means you have a service for this. You want to create a container. You have a service for this. You want to work in database. You have a service for this. You want to write a code. You have a service for this. You want to create a CI/CD pipeline. You have a number of services in this. You want to create a storage. You have a service in this. It means for every purpose in AWS, you have a service. And the same pattern is being used in Azure as well as in GCP. It means what is important for you? What is important for you? So to learn about those services properly, to learn about those services. Is it clear, everyone? Now, I'm just going to create an administrator user. And that administrator user I will use in my entire course. You can use root as well. Nobody stops you, right? But what are the best practices? I'm telling you. Even if you are working in a company or in a working environment, so no one uses root user. This is not a good practice. Because if something happens wrong in your AWS account, so the root user is an ultimate user who can restore your account. Video link says root. No, that's fine. What I'm saying, just listen me. What I'm saying, if you want to start working in your AWS account, you should have an administrator user. This is the best practices, and AWS Well-Architected Framework tells you the same thing. AWS Well-Architected Framework. This is basically the kind of a framework AWS has created. If you read it, this is really, really important, in which all important things are written. All important steps. I mean, the steps means what is better for professional, what are the best practices, everything is written in this. What is the name of the document? AWS Well-Architected Framework. Yeah, please listen me very carefully. So please note down somewhere. If you are taking my lectures, I think you should have a one copy with you, one pen with you. And if anything which is not clear, you please note it down and clear that concept with me, very clear. So how to how to create your administrator user. To create an administrator user, you should have a root access. So right now I'm in a root. Do you see? I'm in a root. And here, this is a search. This is the search box. Here I did write the name of the service, IAM. And you press enter IAM. I pressed enter and you landed in IAM dashboard. So this is a IAM service dashboard. Left hand side, you can see access management. Under access management, we have user groups, users, roles, policies, identity providers. Do you see? So you click on users. What I want to create, I have already number of users. Admin user, dev user, John user. Let me delete everything. I don't need that, right? I think the someone has access key, so I'm deleting. Please, you don't delete anything, and yours account will be a new one, so you will not find any. So what a fresher, and if you open it very first time, what you will see, I'm going to I'm going to just confirm you. I'm going to just confirm you right here. I think I should. Mhm. So if you open this IAM, if you open IAM, right, and you see very first time, let's say this is the screen, you click on users, you see there is no user, but you open through the root user. Here you are the root user. Can you see? If you click on the root, right inside on the top, what you see very first, account ID. What is this account ID? This is your account number, AWS account number. This is a unique AWS account number. Every AWS account has a unique account number. Then this is my account name. Account name could be anything. And everything is perfect. Now, what I'm doing, I'm creating a user. Click on users. Right inside, I can see create user button. Click on the button. And here you will write, let's say I'm writing admin. Let's say this is my user. You can write your name as well, right? Anything. And now, do you see this option provide users access to AWS Management Console? It means I want to access my account through a browser. Through a browser means I want to access my account through my laptop's browser or my mobile browser. Generally, people are using laptop because I want to see everything, right? And it is only possible on a big screen, not on your mobile phone. By the way, AWS provides you uh, applications, mobile apps to access AWS. Now you can select this one, and there is a console password. There are two options, auto-generated password or custom password. You write your custom password. Let's say I'm writing a custom password here. And this option is not required because I don't want to reset my account or password at next login. So you can remove this check, go down, next, and we have the, I'm not teaching IAM right now, okay? I'm only teaching means how you can create your AWS account, administrator for administrator. So this is the third option, attach policies directly. You select this option. Third one, attach policies directly. You have number of permission policies here. Scroll it down. Do you see one policy, administrator access? Otherwise, in the search, you can write here, administrator access. So you can see this is, I was looking for this permission, administrator access. You select this permission. Only one permission is sufficient here. And now click on next and scroll it down. Next. And this is the URL you have. Okay, this is your user account. admin, and this is the password. If you don't know what is the password you typed here, you click on this show button, the password is visible. And if you want to share this information with your teammate, you can also send an email. Right inside, we have an email option, email sign-in instructions. Click on this and you can send the email. Through the email, you can inform about what is your AWS URL, username, and password to log in. But what shall I do here? So first of all, you click on return to user and continue. So your user is done. If you click on the user, this is your user and this user has a administrator access permission. So everything is fine. So you successfully created a user. Now I want to switch as a user. How to switch as a user? So right hand side on the top, do you see root here? Click on root. And if you click on the root, and we have add session. Add session. So simply click on add session. Simply click on add session without logging off, right? Without log out from the root. Now you can write the username. What was the username? Admin. And here is the password. Now simply click on sign in. And this is my AWS account ID or my AWS account number. And simply click on sign in. What an incredible thing is happening here now. You see. Great. Now, right hand side on the top, what name do you see here? What name do you see here? Admin? Yes or no? An admin can do everything. Great. So you successfully created admin user. You logged in as an admin user. Now I can start working on this. And this is my console. If you want to come back to your landing page, do you see left hand side on the top? This is AWS icon, AWS logo. You simply click on this AWS logo. You will come back on this console. So this was really important. That's why I explained actually everything. Now we are going back here. What is the cloud computing? Simple. Cloud computing is what? Delivery of hosted services over the internet is termed as cloud computing. Little bit confused. What are the hosted services? Like the DNS service, your database service, your storage service, your other services, network services, your firewall services. All these basically comes under hosted services. It means you can access these services of AWS over the internet. And through your internet browser or any other application interface, you can access those remote data centers. You can create your virtual machines. You can create your networks. You can manage your storages. You can create your databases. Everything from the remote location. So this kind of environment, this kind of a structure is known as a cloud computing. And the most important is the cloud computing basically provides you on-demand delivery of IT resources. For example, if you create two machines, you will pay only for those two machines. Not only this, let's say you create that machine. For example, I'm just removing this. Let's say you have a machine, right? You have a machine. This is the one machine. This is the one machine. This is the one machine. You have a storage here. Let's say this is a storage. This is a storage. What is the storage service? The storage service is S3. And your machines are created in EC2. Okay, so you have virtual machine 1, virtual machine 2, virtual machine 3. So you create this machine and start using for 2 hours, for example, 2 hours. So on the basis of specification of this machine, you will only pay for 2 hours because after 2 hours maybe you have stopped that machine. Let's say you open this machine for 1 hour. You use this machine for 1 hour. So it means you will pay for 1 hour. And let's say you open for the entire month. Let's say 72 hours. So you will pay for 72 hours for the entire month. So this is called on demand or in scale pay as you go pricing model. What do you call it as a pay as you go pricing model. This is not the only model we have. We have other pricing models as well. We will discuss about those pricing models. Let's say you have a machine. You have a machine and because I want to save the cost of the machine and I need this machine for regularly for 3 years. Let's say this is your application server. You never stop it. If you are purchasing this machine for the 3 year time, will AWS give you any discount? Yes, AWS gives you a very good discount if you are purchasing your instance for a longer period of time. Let's say 1 year, 2 year, 3 year, 5 year. And here you can save up to 72%. How much you can save up to? This is a big figure, right? This is really big figure for big businesses where the machine is not being stopped. You are using that machine regularly. Nobody stops web servers. Have you seen that? If you have a web server, you are doing a good business. You have an online business. So anybody stops the machine? No. It means you will you will running that machine in a unstopped way. Means continuously you are running this machine, and that's why we can purchase this machine for a longer period of time, and we can save money. Similarly, if you have a storage, and in storage you storing 100 GB data, so you will pay for 100 GB per month. You will pay for 100 GB per month. Maybe you have 10 TB data, so you will pay for 10 TB data. And within the storage, further we have a plans. We will discuss about those plans. So pricing is a very important. As a business person, as a senior person, as a project manager, right? Or if you're communicating all these facts with your clients, you should have a very real idea, means how actually AWS is charging. So definitely we will try to cover it. Is it clear, everyone? Good, good. Okay, so we are coming back. So cloud computing, I don't, I will share all these things, right? What are the hosted services? These are the basic things. Infrastructure as a service, platform as a service, software as a service. Infrastructure as a service, the services which are responsible to create infrastructure, like your virtual machine, like your network, like your functions. So where the compute resources are being used directly or network services are being used directly, that comes under infrastructure. Second is a platform as a service. Platform as a service means you do not want to create your platform. You want AWS to create your platform, but you deliver your applications. What you're doing, you deliver your application, you upload your application, and once the applications are uploaded, automatically the infrastructure is created by AWS. So such type of services comes under platform as a services. Third is the software as a services. So software as services, I think you know better, like Google Drive, like Gmail, like Office 365, maybe ERP software, CRM softwares. But in the AWS, we have many other services like SES, simple email service, just like a MailChimp. You know about the MailChimp? MailChimp? MailChimp is a email marketing service, which is software as a service, which is a software as a service. Similarly, very similar to MailChimp, we have a service in AWS which is known as SES. simple email service. Simple email service. Are you getting it? So it means in AWS, few services are software as a service, but most of the services are infrastructure as a service. Because in AWS, you are responsible to create infrastructure. You are responsible to create infrastructure for your application, two-tier application infrastructure, three-tier application infrastructure, three-tier architecture, two-tier architecture, right? How you would create. So here in Solution Architect, we need to focus on these areas. Okay. So this is your traditional data center, and this is very organized data center. Maybe you can see AWS data center. And these are the some challenges. I'm not going to cover all these things. These are the very basic things. Means what challenges you are facing when you create your own data center. What challenges are there? You are responsible for everything. You are responsible for capital expenditure, operational expenditure. You are responsible for hardware management, software management. Scaling challenges are there. You are responsible for power and cooling systems because you need to provide redundant, right, uninterruptible power supplies. You are responsible for security. There are the two types of security: physical security, cyber security, and many other factors are there, right? So we will discuss about it. Now, here, this is a very important question. People generally ask me, sir, we have Azure, we have GCP, we have Oracle, we have Alibaba, we have AWS, but why we are focusing on AWS? Very good question. Very nice question. The thing is, the presence of AWS on this globe is the largest. Number one, the infrastructure of AWS is number one. Not only infrastructure, the total share market in cloud computing is more than 32% of AWS if you're talking about AWS only. Not only this, in AWS, we have more than 200 fully featured services. I told you what are the services. For every need, we have a service in AWS. You want to create a machine, we have a service. You want to create a network, we have a service. For every need, we have a service. Okay, you want to implement a firewall, we have a service. Okay, you want to implement a security, we have a service. For every purpose, we have service. You want to implement, you want to learn AI/ML, you want to implement your project in AI/ML, we have number of services. You want to work in IoTs, we have a services. So for every purpose, for every need, we have a service. So we have major and minor service. What are the major and minor services? Let's say I'm talking about EC2. EC2 is a service which is known as Elastic Compute. Right. This is your EC2 service. So this is the one service. So let's say this is a major service. This is the major service. But within this, we have many services like snapshot, like AMI, minor services like EBS, right? Like ELV, like many other services are there. 10, 15 services are there, sub services are there, or you could say minor services are there within this EC2. So the total number of minor services, major and minor services, are more than 1,500. So one thing is very clear: this is not possible for a person to learn everything in one go. You need a time. You need a proper time to learn about this, right? We have development services, we have architecting services, we have security services, we have administration services, right? We have data analytics services, we have media services, IoT services. So this way, total number of major and minor services are more than 1,500. Is it clear? Now, now we are going to teach about Azure alongside. No, this is only AWS Solution Architect. In this, we are not going to mix any other cloud platform, right? Okay. Now, so the very first concept that we are going to study here is AWS Cloud Infrastructure. What is a infrastructure? Understand what is the infrastructure. So what comes under the infrastructure? So when you say AWS Global Cloud Infrastructure, so regions, availability zones, data centers, right? Edge locations, direct connect, wavelength zone. Let's say I'm writing WZ and local zone, LZ, for example. So these basically are the part of AWS global infrastructure. And we are going to study one by one. Wavelength zone, WZ wavelength zone, and LZ for local zone. Is it clear? Okay. Now, first of all, what is region? Region is a geographical location. Do you see here? Do you see here? This is a region. This is a geographical location. Let's say in India, how many regions we have? In India, how many regions we have? Two regions. One is Mumbai and another is Hyderabad. Okay. But where you can see those regions? So simply go and click on AWS Global Infrastructure. You go there, go a little down. You can see this is your globe, right? Can you see this globe? North America, South America, Europe, Middle East, Africa, Asia Pacific, Australia, and New Zealand. If you go a little down, let's say I'm talking about Asia Pacific. Here you can see. This is India, right? We have one in Mumbai, another in Hyderabad. If you see Europe, this is Europe. You can see in UK, one is Europe and another is Ireland in Europe. And you can see all these black dots. What all these black dots are? These black dots are regions. What is a region? A region is a separate geographical location. Right? Geographical location. So within this geographical location, you have multiple AZs. AZs known as availability zone. Availability zone. What is the availability zone? Availability zone is a logical thing, or you can say it's a group of data centers. It's a group of data centers, logical group of data centers. So within a region, you have number of data centers. So AWS make a logical group of data center, which is known as availability zone. Why availability zone is created? It is providing high availability. Let's say, for example, your client says, I need a highly available virtual machine. I need a highly available virtual machine. What is the meaning of this highly available virtual machine? It means the machine should not be stopped. Even in one server is failed, one machine is failed, one virtual machine is failed, you must have your standby machine in order to provide high availability. Am I correct? So it means in a one availability zones, we will not create a machine. We will create a one machine in a one availability zone and another machine of a similar set, we will create in a different availability zone. Even if your one availability zone goes down, So your application is accessible from another availabilities. Okay. Now, so this is your availability zone. And what is this green color? What is this green color box? It's a data center. Let's say this is your DC data center. So we have a group of data centers in a single availability zone. So let me tell you very simple thing. Okay. What is the mean by logical grouping in the context of availability? Logical means it's not a physical thing. Logical. Logical is not a physical. There are two things. One is logical, another is a physical. Physical, you can touch, you can feel. But logical is just kind of imaginary, but it is not physical. Is it clear? Okay. So, guys, I'm going to create, let's say, region here. What exactly is region and what consists inside a region? Do you see this is my, let's say, rack in a data center. What is the rack in a data center? What is rack? Rack is a kind of almirah in which you install your blade servers. Let's say these are the blade servers. These are the blade servers. You have multiple blade servers. You're going to see these are the blade servers. You also install power supply, router, switching devices here. Let's say this is your power supply. This is your, let's say, router. And this is, let's say, your switching device. And all these are your blade servers. And on these blade servers, you create virtual machines. So these are virtual machines, right? These are the virtual machines. This is the one single rack. So I think you're clear what is the rack I'm talking about. Okay. Now, in a single data center, you can have a multiple racks, correct or not? Yes or no? You have multiple racks. So maybe 10 racks, 20 racks, 100 racks, 1000 racks, depend on the size of your data center. So this is your one data center. Let's say this is your data center. This is your data center. And if you see, this is your, let's say, complete data center. And we have multiple data centers. So this data center can be in a one building or can be in a multiple buildings. You have multiple data centers. So multiple data centers. So we can say this is your availability zone, right? This is what? This is your availability. This is your availability. Will it be okay? So one availability zone has multiple data centers. This is one. And in a region, you can have multiple availability zones. Let's say this is a region. This is what? You can say this is your region. Let's say this is your region. So this is your region. Let's say I'm taking an example of Mumbai region. Let's say I'm taking an example of Mumbai region. Every region has a city name, Mumbai, and every region has its code. Let's say the Mumbai code is AP South 1. This is the AP South 1. Region is Mumbai and Brief code is AP South. Is it clear? So similarly, you can talk about London, you can talk about Northern Virginia, you can talk about Ohio, you can talk about Hyderabad. So this is a region. Yes, we can have a DC even in different cities, but it should be in a 100-kilometer radius. It should be in a 100-kilometer radius from the center. From the center, it should be in a 100-kilometer radius. So because this is a logical region. This is a logic. This is a region, right? And in this, we have multiple buildings, multiple availability zones, multiple data centers. So this way the things are created. And not only this, how many availability zones we have in Mumbai? 3. So what is the name of availability zones? So the availability zone is, let's say, AP South 1A. The first availability zone is AP South 1A. Second is AP South 1B. This is AP South 1B. And the third is AP South 1C. Done. This way, we can give the name to these availability zones. AP South 1A, AP South 1B, AP South 1C. And we have a multiple availability zones. Let's say this is your one region. This is another region. Let me, let's say this is another region. Okay, this is North Virginia. Now, we can make a connection. So AWS is providing a connectivity, a dedicated connectivity between these two. And these connectivity is created and maintained by AWS. Let's say this is the connectivity. So this way, these two regions are connected, not using a single link. So these connectivities are using multiple links. Even if your one link is failed, your another link is available. Correct? So this way, all this. So this is a basically very simple idea about AWS global infrastructure. So how many regions we have? How many regions we have? So as of now, we have 38 live regions. Let me double check. I 38 or 39? 39, sorry. Now they have changed 39. So we can use 39. Total 39 regions are there. And how many total number of availability zones? 123 availability zones. So day by day, infrastructure is increasing. So this is 39 live regions we have. And in 39 regions, we have 128 availability zones. And we have more than 700 edge locations. Edge locations. What is the edge location? Let me tell you one thing. What are the edge location? Edge location. Here you can. Right. So we talked about the first of all. This is a picture of our globe, right? In a flat pattern, you can see all these green color are live regions. Red color regions are not yet live. If you go a little down, this screen you can see, this diagram you can see, we have a region. In a region, let's say I'm taking a Mumbai region. We have 3 availability zones, AZ1, AZ2, AZ3, AP South 1A, 1B, 1C. And within every availability zone, let's say I took three data centers to show you this picture only. So these are the data centers. And if you see the bottommost layer, this one, red color boxes, these are edge locations. What these are? Edge locations. And these edge locations, we have a multiple purpose of these edge locations. But the basic purpose, the number one purpose is providing connectivity between data centers. Number one, these edge locations are also known as mini data centers. These are the mini data centers. And edge locations are also used to deliver content globally. We are using these edge locations for CDN, content delivery network. In these edge locations, we have networking devices such as routers, switches, and also containing number of servers to cache memory for CDN, for content delivery. You can find these edge locations in all major cities. Let's say New Delhi. New Delhi, we don't have any region in New Delhi, but we have a edge location in New Delhi. Correct. So more than 700 edge locations. So let me see what is the number. What is the number? The number are written about the edge locations. I don't know. See, you can see. Yeah, 750. Oh my God, the number is changed. So let's say I'm changing this number as well. I'm changing the number as well, right? 750. More than 750 edge locations. Locations are there in AWS infrastructure. We are using these edge locations to distribute our content at low latency. So Netflix is the OTT platform. So Netflix is the one customer of this CDN technology or CDN feature of AWS. So Netflix is using CDN of AWS to distribute content. And you find that without any latency, you can access the programs over Netflix. Correct or not? Okay, fine. Now, here we go. We'll talk about other few things. Local zone. What is the local zone? First of all, where we can see this is your AWS, right? So in which region right now I'm working, you can see the list of regions here. This is your AWS console. Oh, yes, you can see this is AWS console. If you click on this region tab, you can see the list of regions here. North Virginia, Ohio, California, Oregon, Mumbai, Osaka, Seoul, Singapore, right? So let's say I want to work in Mumbai, you can click on Mumbai. Now you are in Mumbai. If you want to work in North Virginia, it's okay. You click on North Virginia. You are in North Virginia. You want to work in London, you can simply click on London. See here, you are in London now. So how to choose your region? In which region you should work? What factors will decide what region you should choose? It depends on your client's workload. It depends where is your client. Let's say you are in India. Just assume your company is in India. For example, let's say I'm giving you some scenarios on the basis of that. Let's say this is your company. You are a developer company, right? Let's say company ABC. Okay. So this company is situated, you are running this company from India, but you are making a software for UK people. Let's say UK. So your client is in UK. Okay. So this is your client. Client is in UK. And the user of applications are also in UK. Users of the application are in UK or near to UK or Europe. So majorly UK. So this is the use case. So which region you should use to deliver services? You have two options. Mumbai is in India, or London? Which region you should use? Guys, hello? London, right? London. Why? Because the London is very near to your users, right? Because London is near to users. And if your client is in UK, users are in UK, so you should implement this application. You should create this application in London. Because if you're creating application in London, you're deploying this application in London, it means the latency is low. Is it clear? The latency is low. Latency is low. But if your client is in India, then what you will say? If the client is in India, then what you will say? Then you will not choose London, you will choose Mumbai. Then you will choose Mumbai. So it means it depends on the use case, which region I should use. Correct or not? It depends on the use case, company to company. We have a big company. Let's say this is a company head office. This is the company's head office, headquarter, whatever. Head office, and head office is in, let's say, in Mumbai. For example, there's a pharmaceutical company. We have a very well-known and popular pharmaceutical company in India. So, and this company has number of branch offices. This is a, let's say, one is in London, another is Brisbane, let's say in Tokyo, maybe in Berlin, maybe in somewhere in let's say America. Okay, let's say this is what. So this is the case we have. And client says, or our partner says, we want to handle our work our own. We are responsible. We want to give our own resource cost. So we don't want to give the control to any other. So in that case, you can create multiple AWS accounts. What you see here, you create a multiple AWS accounts. You can create accounts for every client. You will ask your client to create a multiple AWS accounts. And these multiple AWS accounts are managed by one administrator, right? So we have a team in Mumbai, and this team is managing multiple AWS accounts. Or maybe we have a branches of our company in a different cities. So this way, sometimes this is very important. We should manage all these accounts. We are responsible to manage multiple AWS accounts. So this is a one also use case. Everything is clear till here? Okay. Because people ask sometimes, sir, why we need multiple AWS account? Why don't you can have multiple clients, you can have multiple projects, you can have multiple offices in multiple cities, right? So it means that one account is not sufficient to deliver services because you want to keep their uh, resources. Billing can be integrated. Billing can be integrated. If you want to give billing separately, you can give separate bill. And if you want to integrate total bill of all these AWS accounts, you can also integrate all the bills at one place. Right? And you know that this service is being used to uh, means connect all these accounts. Very, very basic service. We have a service called organizational unit. OU, or the service name is organizations. Right, we will use organizations. Under the organizations, we can create an organization unit. And here we can create an hierarchy of all these AWS accounts. Right. So we will see later. But this is really interesting. Now we talk about, let's say, local zone. What is a local zone? See, there is a challenge. Let me tell you what is the challenge. And with the help of the challenge, you can understand why local zones are needed. So, see, first of all, see the definition. What is the local zone? These are special type of zones, local zones. And local zones are created near to large population or near to IT and industrial hub, where you find, but the region is not there. Let's say this diagram you can see. This is my Mumbai region, right? This is my Mumbai region. And I can see 3 availability zones here. So, and this is a really highly populated. But my company, my another company is in Delhi. So there is a one business which is in Delhi or in NCR. And we have a data center of this company in Delhi. Are you getting me? Now, we need to use AWS services. But the problem is the distance between this physical data center or private data center and this Mumbai region is approximately 1,500 kilometers, approximately, maybe a little more. So approximately 1,500 kilometers. And you want to integrate, you want to create your hybrid cloud, you want to connect your data center with the AWS. So if you connect, you will find some latency, right? So in order to eliminate that latency, what AWS does, AWS provides you in Delhi, in your area, local zone. So it means you can create your workloads, your AWS resources in this local zone. So what facility you will have? It means if you connect this local zone with your private data center, so without latency, you are able to connect AWS with your private data center without latency. But why it is only in Delhi? Can we find this local zone in all other cities? No. We have a limited number of local zones. We have a list of local zones throughout the world. In Delhi and Kolkata, in Calcutta, it is these local zones are available, right? So this way, east, west, north, south, every corner of India has been covered. Because in east side we have Hyderabad, in west side we have Mumbai, North India, right? So this way you can take very east, most east is Calcutta, in South Hyderabad, sorry, Hyderabad is south, right? So this way you can cover entire India. That's why the local zones are created. But local zones are a little bit from availability zones. But where you can see those local zones? Do you see, this is my AWS console. You can simply click on EC2 to open EC2 service. You open EC2 service. I told you the local zones you will select to make connection with your private data center. Let's say your company is in Delhi and you need a local zone to deploy your machines and connect with your private data center. Okay. See, instances, you go to instances. So you can create an instance. Availability, sorry, this Mumbai is region. You have use region. But if you go to dashboard, if you go to the dashboard and scroll it down the dashboard a little bit, you can see count attributes. And under account attributes, we have a settings. And under settings, I can see zones. Do you see? Zones. So if you click on zone button, another page is open. Just a minute. I'm just going to read it and answer. Wait a minute here. So you can see number of regions, availability zones, local zones, and the list of wavelength zones. Do you see availability zones? These are the regions. These are the regions. These are the availability zones. Do you see? And you can see the local zone. We have a local zone in Delhi. We have a local zone in Kolkata. We have a local zone in Philippines. We have a local zone in Australia, Germany, Poland, right? We have a limited number of local zones. You cannot find local zones in every city. But where the need is required, need is there. So AWS created a local zone. And another is a wavelength zone. So I think the purpose of the local zone is clear. What is the local zone? Right. Here is another type of zone which is now these days in a discussion, wavelength zone. What is a wavelength zone? So wavelength zone is created mainly for 5G mobile technology. 5G mobile technology. Let's say you have 5G mobile device in your hand, but you are not using 5G mobile apps. So it's happening these days. You have a 5G mobile, but you are still using 4G application. Why we are using 4G application? Because the infrastructure is required in order to implement 5G mobile applications. Am I correct or not? So AWS gives you a platform to launch your 5G mobile application in a wavelength zone. These are the special type of zones which are not in your regions, which are not in a specific city. These wavelength zones, these type of zones are created within the infrastructure of telecommunication network provider. Let's say in India, we have an Airtel company. I'm taking an example, or Jio, we have a company. So in their data center, AWS provided some resources or AWS integrated some services, or sorry, some hardware resources to launch 5G mobile applications. So why? The reason is very simple: to reduce latency. I don't need even 1 millisecond latency. In some cases, very, very important, because the kind of technologies we are using, let's say automatic uh, application to drive your car, or any application to drive your car. Do you feel there should be a 1 millisecond latency over there? No, not never. Because if you have a millisecond latency, in that case, accident can happen. Accident can happen. So that's why we need a kind of uh, result from that application with a zero latency. With a zero latency, we need a good response. Zero latency response is required. So that's why we are using the spatial type of zones. And these spatial type of zones are known as wavelength zone. So wavelength is an infrastructure offering optimized for mobile edge computing applications. This is basically meant for 5G mobile technologies. Wavelength zones are AWS infrastructure deployment that embed AWS compute and storage services within telecommunication providers center at the edge of 5G network. Yeah, they are responsible. AWS is responsible for the security. They are monitoring. They are monitoring, and they are not leaving the control to any third party. They are managing all the resources. They are managing hardware. They are managing security. They are only basically providing connectivity to telecom network provider because they launch their hardware in their premises. So this way, the response time will be reduced, latency will be reduced. Is it clear? Okay. So as of now, we do not have any wavelength zone in India. If you want to see, you can see wavelength zone here. So Asia Pacific, Tokyo, Central Canada, London, Paris, and most of wavelength zones are in North Virginia. So AWS is working on this, right? And Oregon. That's all. So few wavelength zones are in Paris, London, Central Canada, Tokyo. That's all. Not even in Beijing, correct? And North Virginia. Done. So this is your AWS global infrastructure. And the last thing that I want to discuss is direct connect. What is a direct connect? Direct connect is a service to integrate AWS with your data center. This is your data center. This is your private data center. And you want to connect your private data center with AWS. So this ultimate cloud is known as hybrid cloud, because you are going to connect the private data center with the public cloud AWS through a service called Direct Connect. This is a service. AWS is providing this service, right? What is a Direct Connect? Direct Connect is a service name. But when you purchase this service, AWS install a physical line, and that physical line terminates with your endpoint router or end gateway of your data center. And you always purchase a bandwidth of this broadband, or you can say not broadband, dedicated line. So let's say 10 Gbps, 50 Gbps, 100 Gbps. So up to 400 Gbps you can purchase. 400 Gbps is a very expensive, of course, right? So you will purchase as per your need, as per your demand. The more bandwidth you purchase, more money you will pay. So if you want to connect your private data center, private cloud with the public cloud, with AWS, which service you are using here? Which service you are using here? Direct Connect. Are you getting me, guys? Direct Connect. And what type of a cloud it is? Hybrid cloud, right? So in order to create a hybrid cloud, which service you are creating? Direct Connect. Okay. Now, guys, I think this is fine. So this part is done. Now, the next thing we are going to discuss is services, and then I will explain all these services one by one. So we have 4 services. We need to discuss about the 4 services: EC2, S3, RDS, and VPC. I will be giving some overview on these services, right? And not only this, I'm going to, let's say, include some services. Let's say I'm including some services. You can use Route 53. Route 53. This also is a very important service.
So a quick pause, knowing what these services do is one thing, and recognizing how AWS twists them into a real SAA-C03 exam question is different. And that's where most candidates get stuck on the first attempt. And to solve that, we have put together a free AWS Solutions Architect Q&A guide with the exact question patterns from the actual exam, the same one Srikar and Saif used while preparing. Also, if you want to go deeper, we also run a live AWS SA Masterclass where trainers who have architected AWS systems for enterprise clients answer your prep questions in real time. So both the links are there in the description below. Grab them before we move on. So let's get back to the video.
Okay. We can also discuss about tier 3. So now I'm just going to give you a little idea about all these services. Definitely, I'm not using any practical here. So guys, here I'm going to take an overview of all AWS services, major services. Only I'm talking about some important services, right? Overview of some important AWS services. Important overview, right? Are you ready? So first of all, left hand side, I told you for every purpose we have a service, right? You know what is a virtual machine? Let me tell you. Uh, uh, okay, I asked one thing from you people. Do you know the technology virtualization, about virtualization? So what you normally need in your data center to create a virtual machine in your data center, in your cloud data center or in your private data center, what you need in order to create a virtual machine? Anybody? VPN is not required. Sorry, VPN is not needed. Yes, I have one correct answer. Rajesh, hardware routers are okay, but what you need to create a virtual machine? The right answer is, Dayakar is giving the right answer. Hypervisor. Hypervisor is needed. No, internet is different thing. Let me give you a very simple example here. What is this? This is the bare metal. This is your hardware server. Let's say this hardware server is a Xeon Intel micro containing Intel Xeon microprocessor. And in this server, we have 16 virtual CPUs and 128 GB RAM. Do you see here? So we do not install any operating system on this bare metal. We do not install Linux. We do not install Windows. What we install directly? We install directly hypervisor, type 1 hypervisor. Let's say VMware ESXi, Microsoft Hyper-V, or Zen hypervisor. These are some popular hypervisors. So whether you are launching virtual machine, you are going to launch your virtual machine in your private data center or in AWS data center, you need a physical machine over there. But on the top of that physical machine, one hypervisor is the type 1 hypervisor. What this type 1 hypervisor does, so it shares the resources of your underlying resources among virtual machines. It is responsible to create virtual machine on the top of this. So this is your virtual machine. This is your virtual machine, right? And every virtual machine is an isolated. Every virtual machine. So in this virtual machine, and every virtual machine has its own configuration. So let's say you are allocating 2 virtual CPU and 4 GB RAM. So this 4 GB RAM and 2 virtual CPU is taken from here, from underlying bare metal server. And who is sharing these resources? Hypervisor. So here we have a virtual machine. And on this virtual machine, we install one operating system, which is known as guest operating system. You can install Linux operating system, Windows operating system, any other flavor of Linux or Windows 11, right? And on the top of this, you have an application. You're running application on this. So all these machines are isolated. If something happens wrong to this machine, that will not impact any other machine. All machines are isolated. So the similar structure is maintained in AWS as well. But who is responsible to configure and install this hypervisor? AWS. AWS is responsible to install this hypervisor in their data center. Not, we are not. We will use service to create virtual machine only. What we will do? We will use service to create virtual machine. We are responsible only to create this virtual machine. So we have an environment. We have AWS management console. In that console, we will choose first of all service, and then we will launch virtual machine. Simple. And this bare metal also is connected with a storage. These are the drives of these virtual machines. These are the drives of these virtual machines. And these drives are known as EBS volume in AWS. What we call them? EBS. EBS, Elastic Block Store. EBS volume. Perfect. See, here we go. And now we need to talk about AWS services. Let's say the purpose is to create a virtual machine. To create a virtual machine in AWS, which service is being used? EC2. EC2 is a Elastic Compute Cloud. This is a service name. Because you should know for what purpose which service is required. If you don't know for what purpose the service, which service to be open, you cannot complete your task. The very first thing is you need to choose your service. You need to select your service. I'm explaining with the help of diagram. Please just note it down. And what is a container? Just like a virtual machine, we have a container as well. Generally, we are using containers for microservices where we have a multiple components of the same application. We run one component in one container, another component of application in another container. Container also is just like a lightweight virtual machine. What is a container? Container also is just like a lightweight virtual machine, but the concept of the container is a little different as compared to virtual machine. But if you want to create a container, we have a service, separate service called ECS. ECS stand for Elastic Container Service. And there is another service called EKS, Elastic Kubernetes Service. Elastic Kubernetes Service, right? Correct. Now, we have a storage services as well in AWS. First of all, talk about the block storage. The block storage that you connect with your virtual machine as a hard disk. So this is your virtual machine's hard disk. So this is a very layman language I'm speaking so that you can understand. But technically we call it as a EBS volume, Elastic Block Storage. So means you use EBS to launch operating systems. You use EBS to launch applications in the virtual machine. So this is a storage of your virtual machine. We call it as block storage. Yeah, this is scalable. This is scalable. This is highly scalable. Okay. But one thing is very clear. Let's say you are using 10 GB storage, 10 GB EBS volume. It means you are going to pay only for 10 GB EBS volume, whether you are using it or not. Let's say you are using 100 GB volume size. So you will pay for 100 GB, whether you are using it or not. Is it clear? Yeah. Object storage. Do you know about Google Drive, OneDrive? How do you see the Google Drive? How do you see? Can you explain what is the Google Drive? It's basically the storage over the internet. Storage over the internet. Am I correct or not? Storage over the internet. And it is connected with your email account. Similarly, here we don't need any email account because we have already registered with AWS. And in AWS, there is a service called S3. S3 is a simple storage service. And this is an object storage. In object storage, you can store any type of data. We will talk about this. Any type of data. You can store images, videos, binary files, text files, document files, any type of data you can store. So I will explain you why actually we are using S3. So S3 is very, very important. And what is the major thing in S3? S3 is a limitless. Right? Limitless. Limitless means you can store any amount of data. The data can be in GBs. The data can be in TBs. The data can be in PBs, petabytes. Okay. So this is the storage over the internet. Secondly, we have NAS. NAS storage service. NAS storage is called, the one service name is EFS. The one service name is EFS. and another service name is FSX. Two services are there, EFS and FSX. EFS we are using for Linux, FSX we are using for Windows. For EFS, but what NAS does? So let me tell you, very simple thing. Let's say in your architecture, you have multiple machines, right? Let's say all these are EC2 instances. These are EC2 instances. So how many EC2 instances you see here? EC2 instances. You see 4 EC2 instances, right? Virtual machines. These are the virtual machines. And every virtual machine will have its own volume. This is the volume, EBS volume, correct or not? This is the EBS volume. Every machine will have an EBS volume where you will launch operating system and applications. But you want to store application data at one central location. And for this, we have this EFS service. What we call it as? This is called the EFS. Let's say all these machines are Linux machines. All these machines are Linux machines. All these machines are Linux machines, right? So this is what we have. So EFS is using protocol called NFS, or you can say this is basically supportable to Linux, and all these machines are connected. All these machines are connected means you can store your data at one central place. You can store your data at one central place. Not this. This is called the EFS. Even if this machine goes wrong, let's say this machine is not healthy, so it doesn't impact on my data. My data is stored in EFS. EFS is highly scalable, and you can also take a backup of this EFS. You can take a backup of EFS. Let me show you AWS backup. AWS backup icon. This is where, this is what. So why I'm doing it? Because you should have a little idea of this, right? This is backup service. This is known as AWS backup service. AWS backup service. You can take a backup of this EFS in AWS backup, right? Clear, guys? Is this diagram clear? Let's say if you are using Windows machines here, let's say you are using Windows machines instead of Linux machines, then in that case, which service you will use here? FSX. And which protocol you will use here? SAB. This is the protocol. Yeah, I will give demonstration how you will cover, because today I'm only teaching you about service overviews. I think this diagram is clear. SMB is a storage protocol. You know what is the protocol? HTTP protocol, TCP protocol, UDP protocol. So under this, SMB also is a protocol for the storage, right? SMB is a protocol for the storage. Now network, if you want to create a network, let's say you want to create a network in AWS. Without network, is it possible to launch machine without a network? In your working environment, is it possible to launch any virtual machine or any container? No, no, no. You need a network. You need a network. So this is fine. Let's say I'm removing this and you need a network. Let's say a network is a region specific. For example, this is your network. So I'm giving VPC here. let's say AWS VPC diagram. Okay. Let me give you a very simple diagram. Yeah. Let's say I'm taking diagram. It's a much complex. Not peering is required. I think this is, let's say this is fine. This is fine. Here, you can see. You can see here. This is your VPC. VPC is a region specific. So you have to decide in which region you have to create a VPC. This is your VPC. This is your VPC. This is your VPC, right? And this VPC is covering 3 availability zones. And these are the subnets in VPC. Okay, when you create a network, you give the range to the network. And this is the internet gateway which is going to be connected. You will connect with the internet to provide internet connectivity to your VPC, right? And here you launch your servers, virtual machines. Here you launch your virtual machines. So VPC, it means this is very, very important. If you create any infrastructure, first of all, you have to create a network, virtual network. So VPC is providing a facility to create a virtual network in AWS, virtual private cloud. VPC stands for virtual private cloud. Now, internet is not called API gateway. API gateway is for the APIs, application programming interface. So in one data center, we can have multiple VPCs. Not in data centers. In one region, we can have a multiple VPC. Because VPC, MUMPC is a region specific and we cannot straight away access data centers. Please correct it. Okay, nice. Now, what is your next service is an application firewall. So firewall name is WAF. WAF is Web Application Firewall. Web Application Firewall. What is a Web Application Firewall? This application firewall basically protecting your application from the outsider attacks like DDoS attack or malicious functions, intruders, right? Correct. So if you want to protect your application from cyber attack or such kind of attacks, you can configure web application firewall. Where you can connect web application firewall, we will discuss about later. Then there is another service called Shield. Right, Shield. The Shield is providing protection against malware attack. Malware attack. It's a malware attack. If you are facing, if application is facing, you can enable it. So there are 2 type of shields flavor here. One is a Shield Basic, another is a Shield Advanced. One is a Shield Basic, another is a Shield Advanced. Shield Basic and another is Shield Advanced. Shield Basic is automatically applied in your account. You have not to do anything. So this is applied. This is already enabled. No, malware activity. Malware activity is, what is the malware? It is different from antivirus. Malware means the kind of act which can harm your application. That may be through codes, that may be through some activity, malware activity, right? So basic shield is applied. But what is a Shield Advance? Shield Advance is only for a critical applications. You will not use Shield Advanced everywhere, but it is a very powerful if your application is really critical, you are doing a very huge business or good business. In that case, you want to protect your application from malware activities. So you can enable Shield Advance, but Shield Advance is little expensive. You have to pay approximately $3,000 per month. if you enable it. How much? $3,000 per month. Oops. So that's why you have to choose very cautiously. Shield Basic is allowed on your AWS, right? I hope this is clear, everyone. Now, second is Lambda function. Let's talk about this Lambda function. The service name is Lambda function. What is Lambda function? Lambda function is a service to run code in a serverless manner. Run code without a server. Run code in a serverless manner. Right. You don't need a code. You don't need a virtual machine to run up. You don't need any container to run up. Directly, you can execute your code in Lambda. There are multiple use cases. You can run your application in a serverless manner. You can run your website in a serverless manner. You can run small code to orchestrate your AWS account in a serverless manner. If you want to integrate one service, if you want to connect one service with another service through the code, you can use Lambda function. Or if you want to run a code on any trigger, if any trigger happen, if you trigger any condition, on that condition you want to run a code, you can use Lambda. Right? Is it clear, everyone? Yes. You can directly say it's an event-driven service. Okay. Second is Elastic Beanstalk. The service name is Elastic Beanstalk. This is a platform as a service. This service is used for application deployment. Let's say you have an application, right? For example, you have a Python application, but you don't know how to configure, or let's say you do not want to consume much time to create compute resources, let's say virtual machine or container. So you configure Elastic Beanstalk, right? This is your code. This is your code, CODE code, right? This is your code. And this is the Elastic Beanstalk. Let's say this is your AWS Elastic Beanstalk. Beanstalk C. So you must be aware of all these icons and images. We will try to use these images. This is there. So you pass your program code application to Elastic Beanstalk. And Elastic Beanstalk will create virtual machine for this code. It will prepare a virtual machine as a web server if you need a web server. And ultimately, you have a machine deployed on this machine. It means you have an application deployed on this machine. So you have to configure Elastic Beanstalk and you will upload your code. And your code is, your machine is created and this machine will contain this application. You can directly use this application using an URL. Executes, what is the meaning of executes? Executes means it runs your program. When you write a program in a Lambda function and when you trigger a condition, that Lambda function is executed, or you can say the Lambda function will run. Your program will run automatically on that particular condition. So the question is, Lambda function is where? Lambda function is a service. Lambda function is what? Lambda function is a service. For example, here you can open Lambda. Lambda is a service. You open a service. You create your function. For example, I'm in Mumbai. Let's say I'm in Mumbai. Simple. See, and I have functions. These are the programs I have written. Okay, so you click on one website. This is my website. I have launched the website. This is my API gateway, which is connected with the Lambda. This is the URL of the application. You copy, and for example, I'm running it. So the program has been executed, right? Or you directly click on this. This is executed. Do you see here? The website is executed. Means your program is executed because you run this program here. This is a function. We call it as a Lambda functions. If you want to create a new function, there is a button called function here. Create function. Just let me create function. So I will teach you step by step. Today, I'm only covering overview of the services. Right? Is it clear? I have a question, very basic question, which is not pertaining to this particular class. What is the difference between EKS and ECS and elastic beanstalk at high level? Okay. See, ECS is used to create a container, elastic container service. What you are creating container? What you are doing here? Creating container. Your applications are in container. Container is a what? It's a lightweight virtual machine. Just very simple definition I'm writing so that you can understand. It's very similar to lightweight virtual machine. EKS is a Kubernetes service. EKS is a Kubernetes service. And we are using EKS, sorry, not EKB, EKS. We are using EKS to orchestrate containers. Containers. You have multiple containers and you want to manage multiple containers. So what we are doing, which service we are using? EKS. What is elastic beanstalk? What is elastic beanstalk? We are providing an application here, right? We are using elastic beanstalk to deploy application in either virtual machine or in container. So where we are using elastic beanstalk, generally, we are using elastic beanstalk generally in CI/CD pipeline. What is the CI/CD? Continuous integration, continuous development. So automatically it will deploy your application in virtual machine. Means elastic beanstalk will automatically create virtual machines and container. You configure your pipeline in such a way. I hope you are clear on this. Now, what is glacier? Glacier, right? See, glacier. Okay, let me give you a one simple use case. You have a big company, right? And you have a lot of data. What type of data you have? Let's say you have last 10 years financial data. Will you delete it, or you want to keep it in some storage space? You have, let's say, last 5 years sales data, which is very important for data analytics, right? And 10-year financial data is required as per our government rules. Government can ask this data anytime. We cannot delete it. Or we have huge data. We have huge companies internal data, or any kind of data I'm talking, that you don't want to delete, because data is what? Data is gold. Just understand. You cannot delete your data, dear. You're doing business, right? On the basis of previous data, you run your business. Correct or not? If the data is not there, what will happen? No, the data is required. So I don't want to delete this data. Where I should store this data? In your private data centers, you can store your data in let's say storage. What type of a storage? Maybe in DVDs, maybe in different type of storages, in tape drives. If in tape drives you store this data, correct or not? But in cloud computing, we do not have any DVD drive. We do not have any access on tape drive. So where I should store this data for a longer period of time, let's say 5 years, 10 years, maybe 15 years. So AWS is providing a service called AWS Glacier. So this is a data archival service. What is it? Data archival service. Data archival service. So at low cost, very important, at very low cost, you can store, you can archive your data for a longer period of time, right? So the concept is clear about the glacier or not? And one more thing I want to add here. I have one more thing I want to add here. Uh, what is that? Glacier is a basically S3, S3's class of S3 class of data. So it's a basically directly pertaining to S3. Is it? So I think I'm covering all the concepts. So please note it down because you will waste your time here. I don't you want to waste your time. So every important thing I'm explaining here one by one, bit by bit. So it means, see, if you here in S3, for example, you are in S3, right? You have a bucket, for example. Let me tell you, bucket is basically the kind of a container we store your data. Let's say I create a bucket and a bucket name is, for example, K21 demo store and today is 18th April. Okay, this is fine. And let's say I have this bucket is a container where I can store my data. And I am going to upload some data. So if you upload some data, so it is not archived. Let's say I have multiple files. Let me take all these files. Okay. Let's say I'm taking all these files. I'm taking all these files, right? Let's say I'm taking all these files. So these files are uploaded in S3. Do you see? All these files are uploaded. Very nice. Succeeded. So we have all these files. Some files are XLS files, some are JPG files, some text file, PNG file, PDF file. So different type of files are there. So these are stored in S3. But do you see the storage class here? Storage class. What is the storage class? Do you see here? What is the storage class? Do you see here? Standard. Standard means you can access your content very frequently. You can use with application without latency. Let's say this data is huge. I have millions of files and I'm not using on a daily basis. Seldomly, once in a blue moon, I can use this, but not on a daily basis, not a frequent basis. So what I will do, it means you will archive this data. What you will do, you will archive this data. So let's say I'm selecting all this data to save the cost because Glacier also is a low cost storage class. Glacier is what? Glacier is a low cost storage class. Standard is a expensive. Right? We're talking about the pricing also as well, right? So now you can go to action, add it. For example, what happened? Reduction, added storage class. And I'm, let's say, choosing Glacier. You can save this. You are going back. Do you see some change here now? What is storage class now. Now your data is in Glacier. It means your data has been archived. Your data has been archived. So this way you can store huge amount of data. And why we are putting the data in archival state? Because to save the cost. To save the cost. If you want to use this data for a regular basis, you can convert back into standard. And then you can use with your application. So difference between object storage and block storage. So I think practically you should know it, right? Let's say you have a virtual machine. We have a one virtual machine here. Let's say I have a one virtual machine here. Let's say I'm taking only two virtual machines. But I think the virtual machine needs operating system, correct or not? Virtual machines need virtual operating system. Without operating system, you cannot have virtual machine. Yes or no? You need an application. You want to install application. You need to install operating system. So where you will install that operating system? So here we have a block storage, right? We have a block storage. This is called block storage. Can you see this? This is a block storage. This is called EBS. EBS. In this EBS, you will install operating system. You will install operating system in this EBS. You will install application in this EBS. So can we say this is a kind of a hard disk of your virtual machine? Can we say EBS is a kind of a hard disk for your virtual machine? Yes or no? This is a SSD volume. First of all, this could be an SSD volume. This could be HDD volume. But this is a kind of hard disk. Hard disk for your virtual machine. A very simple analogy I'm just using here to make you understand that you should not have a confusion. Local storage, right? The local storage. This is a local storage. This is a local storage where you will install operating system, OS, operating system, plus applications. Applications. You can install application plus user data. Is it? You store here in this EBS. But EBS is a part of your EC2 instance. It's a component of EC2 instance. Yes or no? EBS is a component of EC2 instance. It's a part of EC2 instance. Virtual machine is a part of virtual machine. But what is AWS S3? Let's say I'm choosing this. S3 is what? S3 is a service, storage service. S3 is a storage service. S3 is a block storage. S3 is a S3 is a object storage. Object storage. S3 is a object storage. Object storage. And what you can do, you can create a container inside it, means buckets, and then you can transfer data between these machines. These machines can communicate with this S3 storage in order to transfer data. You can store or you can collect data from S3 storage service. Any amount of. I will means tell you in a detailed way. There is a, let's say, Uh, here, where is the, yes, 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 yes. I can see. Oh my God. Where is S3? Where is S3? Yeah, yeah, this is S3. I will explain you later. So it's a big service, right? I will explain you the properties, what is the object storage, what is the file system of this S3. So I will explain you everything. But right now, what I'm telling you, only I'm giving you kind of an overview, kind of an overview. Is it clear or not? But you are saying that what is the object storage? Object storage, you can store any type of data from any operating system. Maybe on one machine, you have a Linux operating system. And maybe on another machine, you have Windows operating system. It is, right? You have on one machine, you have a Linux. On another machine, you have a Linux. But both machines can communicate with S3 storage bucket where the data is stored. It means you can put your data, you can get your data anytime. What is the limitation? There is no limitation. AWS says means technically we do not have any limitation how much data you can store. You can store your data because one S3 because S3 is a service. Just understand, S3 is a service, and within this you can have a multiple buckets, right? S3, okay. You can say this is S3 bucket. Let's say this is bucket. You can see the bucket. You will create a bucket. Bucket is what? Bucket is a container, just like a folder. So you can create multiple buckets here, and all these buckets are in S3. And in every bucket, you can store again unlimited data here. Right. More data you will store in S3, more money you will pay. Less data you will store, less money you will pay to AWS. Is it clear? Now, there is another service called back. What is a backup service? Backup, as the name is specifying, backup, you want to take a backup of your EC2 instance, you want to take a backup of your S3, you want to take a backup of your, let's say, EFS. So, disaster recovery point of view, this sometimes is really important. So, you can use this backup service. Why Glacier is affordable? Glacier is affordable because the data stored in the Glacier cannot be directly accessed from application. These are stored somewhere in your in AWS data center. Those storages are in some isolations, are not directly connected with the services. Separate storage space we are using in the case of Glacier. Okay. Shall I continue? Now, there is a one service called the DNS service. You know, the DNS service is a very important service in your architecture. Without DNS server, you cannot connect your Active Directories. You cannot connect your web servers. You cannot connect your application servers. You need Active Directories. You need a DNS service to resolve name to IP addresses and vice versa. And for that, we have a service called Route 53. Why the 53? Because the 53 is a port number for DNS. Okay. So with Route 53, you can purchase your domain. What you can do with the Route 53? You can purchase a domain. You can check the health of hosted zone. And you can also route traffic. You can also route traffic in a different way in a DNS. The first task I was telling you, you can purchase a domain. You can register domain. Secondly, you can check the health of the hosted zone. Check hosted zone health. And third is let's say routing policies. You can manage routing policies. Is it clear? So this is a DNS service. And one important thing, this DNS service also is a serverless. You don't need any server to configure the DNS service. You don't need any EC2 instance. You don't need any server to configure the DNS service. Incredible, because in your private data center, you need a physical server to configure a DNS. But in AWS or in Azure, you don't need any physical server, any virtual machine to configure DNS service. Correct, guys? What is the routing policy? Is TCP or UDP? It depends. And definitely, you please tell me, Arcel, DNS is using port number 53. Will you tell me the DNS service is a UDP or TCP? It's a UDP. It's a UDP, right? Now, very incredible and important service. I use this service today to create an administrator user. The service name is called Identity and Access Management. Why the Identity and Access Management? We are using IAM service to create users, groups, roles, and permissions. Because in your organization or in any real-time work environment, one person does not work actually. You need a team for that. And team means multiple people are working on a project. And every person has a job role. And on the basis of that job role, you provide permission, separate permission to a user. Some people will have an access on EC2. Some people will have an access on CI/CD pipeline. Some people will have an access on storage services and database services. Some people will have an access on, let's say, analytics services. So according to your requirement and job role in your project, you assign permissions to user. It means you can create user here, you can create groups here, you can create roles here, you can create permission, and you can manage permissions as well. Is it clear? Now, let's say I'm jumping to another service called, let's say you want to design your infrastructure using a code. Okay, tell me, do you know about Terraform? Sorry, I'm just deleting all these things. I'm deleting all these things, right? Terraform. You know about Terraform? Let's say you will help me, I think. What is a Terraform? Infrastructure as code. Right. Infrastructure as code. What you do in Terraform? You automate, you write a script. Okay, what you do? You write a script. You write a script to create and manage infra. Am I correct or not? But Terraform is a third party. Tool. It's not a basically product of AWS. If you know Terraform, you can simultaneously work with AWS and you can also work with Azure. So Terraform does support approximately 40 different platforms. So you can automate your work with the help of Terraform. And for that, you need to write a script. Correct? So similar service we have available in AWS. In AWS, we have a service for infrastructure as a code called Cloud Formation. Cloud Formation. This Cloud Formation is required. We can use here the Cloud Formation. In AWS, we have a separate service called the Cloud Formation. Your question may be asked, sir, why we should learn Cloud Formation if we already know Terraform? Is it necessary to learn cloud formation because I know already Terraform? I'll say yes, this is very important. The reason is because a few services running, let's for example, Elastic Beanstalk. Elastic Beanstalk is using your cloud formation, right? So many other services are using cloud formation within AWS infrastructure for automation. And instead of using Terraform, you can also use CloudFormation in AWS. It does support only in AWS. Yeah, automate the service. CloudFormation is like a stack to automate the services, right? So I think this is clear, right? Now we are going back. What is this? Load balancer. Load balancer is a component of EC2 service. Load balancing. What is the load balancing? Load balancing is providing fault tolerance and high availability. Yes or no? It is providing fault tolerance and high availability. What is the use of the load balancer? If you have huge incoming traffic, so the load balancer will distribute that traffic among multiple instances to incoming the yes. So it distributes incoming traffic and outgoing traffic, or not outgoing, incoming traffic usually, right? Not outgoing, incoming traffic. Incoming traffic. Let's say, here we go. I'm explaining with the help of diagrams, right? Let's say AWS Elastic Load Balancer image I'm taking here. Yes, I think this is better. Do we have any other? Let's say this is very simple. It seems very simple. This is better. So I told you ELB is a feature of AWS EC2. And this is your load balancer. And behind the load balancer, you have multiple instances. This is one instance, this is another instance. This instance is running in availability zone 1, and this instance is running in availability zone 2. This way, you are providing high availability. Not only the high availability, let's say this machine is not available because his health is not proper, right? Let's say this is not healthy instance. Some misconfiguration happened, or because of any other reason, this machine is not available. So the entire traffic will be sent to this machine. So this application is still available for your client. Right. By the way, we are using load balancer to distribute traffic. And for distribution, we can use multiple algorithms, but the default algorithm is round robin algorithm. So it distributes only incoming traffic, not outgoing traffic. Just understand. So we will discuss about there are the multiple type of load balancer. This is the internet facing load balance, which is directly connected with the internet. So internet traffic is being distributed here. But there is a one more type of a load balancer, which is known as internal load balancer. Generally, we are using internal load balancer in a 3-tier application architecture. And we have a different type of load balancer. We have application load balancer, network load balancer, and gateway load balancer. What? We have application load balancer, ALB. We have NLB, network load balancer. And third is called gateway load balancer. And all these three have different use cases. So we will discuss in detailed class where the ALB is used, where the NLB is used, and why and where this gateway load balancer is used. Okay, ALB is application load balancer, network load balancer, and gateway load balancer. So you will select the load balancer on the basis of your application requirement or traffic distribution mechanism. But one thing is very clear. What is ELB? ELB is a load balancer, and which is a component of EC2 service, right? Clear, everyone? I think this is clear to everyone. Good. There is another service called auto scaling. What is auto scaling? Let's say you do not have a sufficient amount of compute resources to handle the load. So you have one machine here, and you feel that your incoming traffic is very high. Let's say incoming traffic is increasing. Incoming traffic is increasing, and the usage of this application also is increasing. So on this condition, automatically number of virtual machines are increased in order to share the load. Automatically these machines will come. So you can scale up or scale down. You can scale in and scale out on the basis of requirement, which is known as auto scaling. Auto scaling. We will learn this in a detail. This also is a basically a service inside EC2. Auto scaling also is a service inside EC2. So EC2 is a big service, correct? Now, the next is the database services. We have two type of database services. One is a SQL database service. Let's say generally, by the way, I'm not going very deep because database is a very big topic. So let's say I'm talking about only two services there, databases. So in databases, let's say we have SQL database, and another is known as NoSQL database. Okay, so both are different. Both are different. For SQL database, we have a service called RDS, Relational Database, or this service has been renamed. Now we call it as Aurora and RDS. We call it as Aurora and RDS. And in NoSQL database, we have a service called DynamoDB. We call it as a DynamoDB. Perfect. So we will discuss about these services in detail in our program. If machines can auto scale, why do we need load balancer? See, a load balancer work to without the load balancer, how you will distribute traffic between multiple machines? Because auto scaling is increasing only machines or decreasing only machines. But how you will distribute load among those machines? And for that, load balancer is required. Is it clear? So these are the services, Aurora and RDS. Aurora is a product of AWS. Aurora is a product of AWS. But in RDS, you can have multiple database engines. Can you give the name of some engines? Let's say MySQL, PostgreSQL, okay, PostgreSQL, Oracle, very nice. DB2, okay, MariaDB, etc. So these database engines are available in RDS. There is a document DB as well. SQL Server, yes, SQL Server also is there, right? You can write MS SQL Server. Okay? Is that clear? But the DynamoDB's concept is a little different. In DynamoDB, you can store unstructured data. structured data or semi-unstructured data. Right? If you have unstructured data or semi-unstructured data, where you will store? You will store in DynamoDB. So DynamoDB is a serverless. In DynamoDB, you have not to create any server. You will directly create a table in DynamoDB. But in RDS, you will create a server first. Right. Here you will create a server, just like EC2 instance. So these are very capable service. You can take a backup, you can create read replicas to share the load, right? Multiple things we can do in RDS. So RDS is SQL database service. Redshift is a data warehouse service, and definitely you can store any unstructured or semi-structured data in Redshift. MongoDB, DynamoDB, it is very similar to DynamoDB, but MongoDB is not a product of AWS. DocumentDB also is a database service to store document database. So it is little different. So we are not covering actually here, and it's not a part of this. But what do you mean by AWS Athena? Okay, very nice question. Athena definitely is not a part of this. Let's say Athena is not there. But why the Athena? Let me tell you. Let's say I'm taking a use case here. Let's say you have S3 service here, right? You have S3 service. This is S3 service. And in this S3 service, you have large number of logs stored in S3. Large number of logs, maybe pertaining to one machine, maybe pertaining to multiple machines, maybe pertaining to your VPC flow logs. You have a large number of logs, and you want to run some queries on these logs, because nobody can manually read these logs. So what you will do, you will choose here Athena. You will use Athena, correct? What you will do, you will use Athena. You will run Athena on this log, and you will have an output. So generally, we are using Athena in analytics jobs. We are using in analytics. And this is very, very important for log readers as well. You want to find out, you want to extract some information from log. In that case, you can use Athena. Does AWS support in-memory DB? Redis? Yes. Yes. We have a service called Elastic Cache. Elastic Cache. Right. So you can create your in-memory resources here. In-memory resources. In-memory database, you can say. Elastic Cache. What is the name of the service? Elastic Cache. Okay. You want to see, you can just go there and simply write Elastic Cache here, in-memory cache here. And both are there. You can see Valke, Memcache, Redis, which you find more suitable for your case. Memcache, Redis, or Valke. So Valke is the latest cache services added in Elastic Cache. So this is also very similar to Redis, but it is little cheaper and better. Next, let's say I'm going back. Security group is just like a machine's firewall. And what to block, what to allow, which particular traffic you want to allow. Let's say port number SSH is allowed, or HTTP is allowed, HTTPS is allowed, NFS is allowed. So you can define your port here, so that only traffic will come to your application or your machine. So this is a port filtration firewall. Second is NACL. NACL is a subnet level of firewall. Security group is a instance level of firewall, virtual machine level of firewall. And this is NACL, network access control list. This is basically subnet level of firewall. So you can apply on subnet to control traffic. And there are some monitoring services as well, like CloudWatch, CloudTrail, Config, and Trust Advisor. Many other services are there. Great. So we'll discuss all these things step by step. So I think you enjoyed today's class.
And that's a wrap on day one. You now have a global structure of AWS and the core services that every architecture sits on. Log this in because every video after this builds on it. And day two is already on its way. So hit subscribe and the bell so it lands on your feed the moment it drops. Also, if you haven't grabbed the free Q&A guide or registered for the live masterclass yet, both links are waiting for you in the description below. And if you have any questions from today's session, drop them in the comments below. Thanks for watching, and I'll see you in the next video.